So, how do we actually take a raw, super intelligent AI and turn it into a safe and helpful assistant? Well, that is the core challenge of AI alignment, and in this explainer, we are going to unpack the secret recipe.
You know, a powerful pre-trained AI is a lot like a brilliant library with absolutely no librarian. It has basically all of the world's information at its fingertips, but it has zero guidance on how to be helpful or honest or, harmless.
And that leads us to the central challenge, right? How do we teach this brilliant system to be a force for good? How do we align it with our values? This is the core problem we're going to get into. Our journey starts at the foundation, teaching by example. The first and most direct method is called Supervised Fine-Tuning, or SFT for short. SFT is pretty much exactly what it sounds like. We show the AI this massive, curated instruction manual packed with high-quality examples. Think of them like thousands of flashcards showing a prompt and the perfect response. The model's job? It's simple. Just imitate those demonstrations.
And this works to a point. It's cheap, it's stable, and it's fantastic for defining the AI's basic persona. But the big limit? It's brittle. If the AI sees a prompt that's outside its training data, it kind of freezes. It doesn't know what to do. It just can't scale to the messiness of the real world, which brings us to a major breakthrough.
To get past this limitation, the next big idea was to stop teaching the AI what to copy and instead teach it what we prefer. This is the core idea behind something called reinforcement learning from human feedback, or RLHF.
Now, RLHF is a multi-stage process. First, humans don't write the perfect answer. They just rank a few different AI responses, saying, yep, I like this one more than that one. Then, a second AI, called a reward model, is trained to act like an AI judge. It learns to predict which answers humans are going to prefer. Finally, the main AI is fine-tuned to generate responses that get the highest possible score from that AI judge.
And this is just an incredible illustration of how powerful RLHF is. The famous InstructGPT paper showed that a relatively small 1.3 billion parameter model trained with this method was actually preferred by humans over the gigantic 175 billion parameter GPT-3. It was more truthful, it was less toxic, it was just better. This wasn't just a small improvement, it was a genuine inflection point for usability. Honestly, RLHF is what turned large language models from just interesting toys into the truly useful AI assistants that we know today.
But of course there's a catch. That whole multi-stage pipeline, training multiple models, running these complex algorithms, it's incredibly powerful, but it's also incredibly complex and expensive. So the next natural question became, could this be simpler?
And the answer, thankfully, was yes. Enter the elegant upgrade, a more efficient path called Direct Preference Optimization, or DPO.
So the crucial difference here is the process itself. Where RLHF is this complicated, multi-stage pipeline that needs a whole separate reward model, DPO is a single-stage process. It directly optimizes the main AI on those same human preference pairs, all in one go, much cleaner.
And the benefit becomes super obvious when you look at the resources you need. The training cost and the complexity of DPO are just dramatically lower than RLHF. It makes it a much more direct and efficient way to get to the same goal.
So it's really no surprise that teams love DPO. I mean, it's simpler because you're only training one model. It's cheaper, way faster to iterate on, and for many key metrics, it delivers results that are just as strong as its more complicated older brother.
But all of these methods, they share one common bottleneck: humans. Getting enough high-quality human feedback is incredibly difficult to scale. This led to a new, kind of brilliant solution: teaching AI with other AI. This is the core idea of constitutional AI, or CAI. Instead of a human, another AI provides the feedback, but it's guided by this explicit set of principles, a constitution. So the AI generates responses, critiques them based on the constitution, and then revises them, creating this really powerful feedback loop for learning. And the results are powerful. As the original paper puts it, this method can drastically reduce the need for human labels while improving harmlessness without the AI becoming evasive. This means it learns to refuse harmful requests while still being helpful on the safe ones. That's a huge deal.
This technique, also called reinforcement learning from AI feedback, or RLAF, completely changes the scale of training. All of a sudden, the vast majority of alignment feedback can be generated by AI, which just shatters that human bottleneck.
Okay, we've covered a lot of ground here, from simple imitation all the way to AI tutors. So let's pull all this together into a clear playbook for choosing the right tool for the right job.
So here's the takeaway.
If your priority is speed and you've got limited resources, DPO is your best bet. If you need to explore new AI behaviors or you need really strict control, the power of RLHF is still the way to go. And if your biggest challenge is just scaling beyond the limits of human labelers, constitutional AI offers an amazing path forward.
You know, these methods represent an incredible evolution in a really short amount of time, but the journey is far from over. Which leads us to the final question. As these techniques keep evolving, what's the next breakthrough in making AI not just more powerful, but a truly trustworthy partner in our world?